our data science series. In this episode, we are tackling the fundamentals of statistics, the backbone of data science. Whether you are new to stats or need a refresher, this video will give you the tools to interpret and analyze data like a pro. So, let's dive in. Okay, so introduction to statistics. The question is, what is statistics? Statistic is the language of data. It helps us summarize information, uncover patterns, and draw conclusions. In this episode, we will cover two types of stats. The first one is descriptive, and the second one is inferential. So, descriptive stats is a technique to summarize data using metrics like mean, median, variance, and so on. While the inferential statistics method like hypothesis testing and confidence intervals to make predictions or decisions based on data. Let's start with the descriptive statistic. So descriptive statistics help us understand our data set at a glance. They include measures of central tendency and variability. Here's how they work. Where I have a data set in which two columns, the first one is age and the second one is salary, and show it in a data frame. Okay, so first we discuss about mean. The mean is the average of a data set. The second one, the median, is the middle value, and the mode is the most frequent. So first we find mean, and the second one is median. And okay, first we will find so here we use mean of the salary. So df, we use the salary column dot now mean underscore salary. Okay, so mean of the salary is 70,000. This one, which is the average value. The second one is median. So again we use the salary column, median salary dot. Now again run the code. Value is it here, median salary. Okay, so the median is the middle value. Now the last one is the mode. So for this age column, mode of the age equal to, now here we use, now the mode value is 25. So 25 is the most frequent value. As you can see, the mean provide an average value, the median gives the center, and the mode identifies the most common value. Serves a specific purpose depending on your data. Okay, now the next we discuss variance and standard deviation. Variance and standard deviation measures how spread out the data. A high variance means the data points are widely scattered, while a low variance indicates they are close together. Okay, now write a code for the variance of the salary. So variance underscore salary equal to, now the salary column again dot variance. Now standard deviation salary equal to, again we use the salary column, and the function is std. Okay, now here we print variance of the is, and the second one is the standard deviation of the salary is std underscore salary. Now run the code. The error is a def salary above except here s should be capital. Okay, now here you can see the variance of the salary and the standard deviation of the salary. So variance is the average of squared difference from the mean, while standard deviation is its square. Both Metrics help us understand data. Okay, now inferential statistics. Here we can write inferential statistics allow us to draw conclusions from data. A common technique is hypothesis testing. For example, we might test whether years of experience significantly affect salary. So here we a hypothesis test evaluates a null hypothesis, no effect against an alternative hypothesis have some effect. So let's see it in action using a test. Okay, so for this we write a code from scipy dot stats import test ind. Okay, now here we use a sample data group underscore one equal to so 50,000, 60,000, and the last one is 70,000. So group with less experience. Okay, the second one is the group 2. So for this we use 80,000, 90,000, and 1 lakh. Group with high experience. Okay, now we perform a t test. Okay, so for this test, t state p underscore value equal to. Okay, so here we use a group 1. Now we print t stat. Okay, now we use a if p underscore value 0.05, print reject the null hypothesis salary, else fail to reject the null hypothesis, no significant effect. Now run the code. Okay, so the p value tells us whether to reject the null hypothesis. If it's below 0.05, we conclude there's a significant effect. Okay, now the next one is the confidence interval. Another key concept is the confidence interval. It tells us the range in which a population parameter lies with a sort of confidence. So for this again we write a code. Import numpy as np equal to and for here we use group 1 and here we use the confidence level. Okay, now calculate margin of error. Declare a variable z score equal to 1.96, which is for 95% confidence level. Okay, so margin of error equal to sample std np dot. Okay, now confidence level lower bound sample mean minus margin of error. Now the next one is upper bound sample mean plus margin of error. Print a message 95% lower bound. Okay, now this confidence interval means we are 95% confident that the true mean salary is within the calculated range. Okay, so to recap, today we explored the fundamentals of statistics, including descriptive statistics, which summarizing data with metrics like mean, median, and variance. The second one is inferential statistics, drawing conclusions using hypothesis testing and confidence intervals. So, statistics is essential for interpreting data and making informed decisions. So, in the next episode, we will explore feature engineering techniques to prepare data for machine learning. Don't forget to like, share, and subscribe to stay updated.